This is a lecture in Chapter 8 where we start with the hypothesis testing. The hypothesis testing is a way for statistics to indicate basically predicting the future. So similar to confidence interval, the calculator will be able to help us with all of the tests running. This is why we were doing stats and then tests, because what we're actually interested in is the hypothesis testing. Most of 8-1 in the book is dedicated for the vocabulary, because number one goal is for me to teach you how to talk statistics. So vocabulary is very important. This video is dedicated to the words that we're interested in knowing and how to type this in using the correct symbols. You will find that Excel is no longer needed for the rest of the semester. What you will find very convenient is a Word document where you can type everything up, and under Insert you have your equation editor. So let's start. A statistical hypothesis is a conjecture about population parameter. The conjecture may or may not be true. So what you're doing is you're using a sample, you're collecting sample statistics to inference about population parameter. Now the parameters that we're going to be using in this class, and this is why I'm doing this in the lecture, can be found under Insert. You have your equation, and what you want to do is you want to choose a script. You want to choose the correct letters. The mu is the population parameter when we are inferencing about a mean, and P is the, let me just put a comma, and P is the population parameter when we're inferencing about proportion. We will not be using any other parameters this semester. We start with a null hypothesis. A null hypothesis states that there is no difference between a parameter and a specific value, or something that we'll study in Chapter 9, that there's no difference between two parameters. So for example, I need to consider a bottle of Coca-Cola that says it has 1 liter. Well, I measure something and it doesn't have 1 liter, it has 990 milliliters. So the question is this close enough? That's what we're trying to deal with. The null hypothesis is labeled with the symbol H sub 0 or H naught. You can find it under Insert, Equation, and you want to choose Script. You want to choose a script that has a subscript that looks something like this. So you're going to put in a capital H and then the 0. This is a representation of the null hypothesis. An alternative hypothesis is a statistical hypothesis that states that there exists a difference between the parameter and specific value, or there's a difference between two parameters. So what we're going to be doing is part of the project is we're trying to inference whether there is a difference between the pulse rate between women and men. So we are talking about two parameters. And Chapter 8 and Chapter 9 is the main setup for the big chunk of the project. Under Insert, I'll choose Equation. I'll choose the same subscript. The alternative hypothesis in our book is labeled with H sub 1. In other books I've seen H sub A, stands for hypothesis alternative, and this is the samples that we're going to be using. Statistical test, a test that is used to obtain from a sample, uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. So we never accept the alternative hypothesis. what we do is we either reject the null hypothesis or fail to reject the null hypothesis. Those are the wordings. So the hypothesis tests can never actually prove something right. What they do is they agree with the original statement or not really do not agree with the original statement or the equal sign. So the wordings will be a bit cumbersome. That's what we're going to be working mostly in class, is how to word this properly. And we'll be using a lot of double negatives, so we'll be very careful. So a statistical test, those are all of the tests that you see in your calculator under the stats button over to the tests. The reality of the semester is we'll actually be going through most of the buttons that are in your calculator. The test value or test statistic is a numerical value obtained from a statistical test. So we'll actually be running those tests, meaning each test has a formula that's embedded within the test. The value, the numerical value of that formula is called the test value or test statistic. What you will see is because we're only doing mu and p, we are only using normal distributions. The only test values that we will encounter this semester is either a z-score or a t-score. So that's what you need to watch out for. Now, a type 1 and a type 2 errors occur when something goes wrong. A type 1 error occurs when the null hypothesis is rejected when it is in fact true, and a type 2 error occurs when the null hypothesis is not rejected when in fact it is false. What I will do is I will do a few examples in the next video to kind of describe the severity of type 1 and type 2 error. The level of significance, we've already seen the significance level in chapter 7. That's my alpha. So under insert, under equation, or you can use a symbol, all we need is a symbol for alpha. The symbol for alpha should look like this. It's the maximum probability of committing a type 1 error. So the probability that the null hypothesis is rejected when in fact it is true. The alpha will be given to you for all of the problems in this book. Although on the project I do not give you an alpha, you get to choose it on your own. The default for alpha is about 5%. This is that 95% confidence that is used most often, where the other 5% is your alpha. It's the probability that we're nowhere near the right answer, basically. Now, a critical region is the range of the test values that indicate that there is a significance difference that the null hypothesis should be rejected. So these are my tails. So I'll draw a picture of level of significance, the critical region, the non-critical region, and the critical value in the next video. But the vocabulary is on this page. The critical region are your tails. The non-critical region is the body of the problem. So this is the range of value where it indicates that the difference was probably due to chance, meaning there is no significant difference. And the critical value is the actual z versus t score that gives you that boundary between the critical region and the non-critical region. So all of these are vocabulary words that will occur in the next test. Unfortunately, I cannot do less vocabulary in the test like some of you asked. So this is a handout that will help you study the vocabulary.